the research is lagging, and that's where me as a processing engineer, I think we can contribute and work with, really throughout the food chain, from say growers, sustainable production of grains, all the way to packaging and transportation, the whole value chain, and how do we look at sustainability, look at the carbon footprint, and understand how we can minimize it.
Something to Chew On is a podcast devoted to the exploration and discussion of global food systems. It's produced by the Office of Research Development at Kansas State University. I'm Maureen Olevnik, Coordinator of Global Food Systems.
I'd like to welcome back our host, Dr. Jim Stack, Professor of Agronomy and Director of the Great Plains Diagnostic Network here at K-State. The study of cereal grains comes in many forms, from fundamental investigations of grain components and their functionality and processing technologies, to the development of healthy food products ready for consumption. In this podcast, we welcome Dr. Sajid Alavi, Professor of Grain Science and Industry, to discuss the importance of cereal grains research in the sustainable production of grain-based foods that represents close to 70% of the world's calorie consumption.
I would like to welcome you, Dr. Alavi, to the Something to Chew On podcast. And I'd like to start the podcast by asking you to just give us a little background and information about yourself, what got you interested in your area of study, and maybe a little background of how you ended up at K-State.
Thank you, Maureen and Jared and Jim. A pleasure to be here, and thank you for inviting me for this podcast. I'm originally from India. That's where I grew up. That's where I went to college. And I'm an engineer by background. And really, what I wanted to, when I was a student in high school, my dad was an engineer, so he kind of influenced me to some extent, growing up in a small town in India. So I wanted to be an engineer. At the same time, I was interested in biology and the plant side of things as well. So when I went to college, I studied agricultural engineering, and that seemed to be a good kind of combination of engineering and biological systems. So that's how I got into agricultural engineering. And as I studied ag engineering, I realized that there are so many different areas within ag engineering, but really food systems interested me the most. And engineering is applied to food systems, food processing. So that really was very fascinating for me, how you could take food materials and apply engineering concepts to them, including processing, machinery, and so on, and convert them into a final product, and really study them from a point of view of physics and math as well. So it was a good combination of biology and food materials and engineering. So that really brought together the two interests. But I must also tell you honestly, I never really wanted to be a professor. If they had voted in my college senior class about the least likely to be a professor, I would be the one. So, but I came to the US for a master's. After my undergraduate in India, I went to Penn State, and this was back in '95. Spent a couple of years over there, and had a great college life, and enjoyed some Penn State football as well. Still young, so Penn State was a great university to study and also enjoy as a student. Even then, I didn't think about the fact that I would even go for a PhD. But one thing led to another, and I happened to see an opening for a PhD position at Cornell University in a food engineering lab over there. So I went for an interview really after I had applied to the graduate program there. And the professor over there, he met with me, and I looked at his lab, and it just seemed to be very interesting. Ithaca, New York seemed to be a great town too. So I decided to move over there for my PhD, not having anything in particular in mind. Spent 4 or 5 years over there, meandered through my PhD, and as often happens with a PhD, and had some ups and downs. But then by the time I was close to graduation, I went to my advisor and I told him, I'm going to be looking for jobs, and I'm looking at some industry positions. And he looked at me and said, Sajid, if you apply for industry positions, don't count on me as a referee, as someone who can write reference letters, because I think you'll be great in academia. And I think part of the reason was because I would always question him, and we'll get into arguments all the time. So he thought that if I'm in industry, I probably would not survive too long, because obviously it's a different mindset, not as free thinking as we in academia. So he said, well, if you go into academics, then I think you'll be a great success. And he really sold it to me. And that's when I decided to apply for a few open positions. K-State was one of them. Also University of Delaware. I went to both places, interviewed, and for whatever reason, Kansas won hands down, so to say. And I was telling Maureen and Jared, he had come from a small town back in India. Manhattan is a small town, and it just had a nice vibe to it, and so that's what brought me to Manhattan, and working in the area of food processing and extrusion, more in particular within grain science. So that's my story, meandering, but I made it here and still here.
Oh, great story. Great story.
Thank you.
So what kinds of things are you working on and teaching here at K-State?
Sure.
There are a lot of things that you're in the Department of Grain Science and Industry, and I don't know that people really understand that entails a lot of different activities. So what's your focus?
That's a good comment, Maureen. So within grain science and industry itself, there are so many disciplines. So oftentimes, even though we're working within the department with colleagues, it becomes a multidisciplinary project. We have people working on the chemistry of grains, protein chemistry and starch chemistry. We have people working on milling of grains, and also downstream baking and feed processing and so on. So my area is really taking raw materials, be it flour or other kinds of raw material, fiber or proteins, and processing them into a finished product using a technology called extrusion processing. And the finished product can be of various types, including food products like breakfast cereal, pasta, snacks, or plant-based meat, which is one of the areas where I'm working a lot these days, and I have a global food systems grant in that area as well. And also beyond food, aquatic feed or pet food is a really big application of extrusion, and even non-food, meaning industrial applications of processing, say bioethanol as an example, or bio-based packaging. Those are various areas that I've been working on over the last several years. So it has evolved, of course, over the years, but most of it is applying engineering principles to grain-based materials, but even beyond, and leading up to a finished product, how to understand the processing of them to get the best quality product, how to understand the quality of the raw materials and how it will relate to the product and the process. So those aspects are what I'm researching, and that also goes into my teaching and a lot of work with industry as well.
Are you starting from available materials, or are you starting from a concept and then you find the materials?
Great question, Jim. Both, I would say, depending on where it starts. So yes, it does start oftentimes from the raw material side. So we might have folks interested in, who would call me and say, listen, I really think we should be using grain sorghum in a gluten-free application. And so that's the starting point. You take grain sorghum, what could be various gluten-free applications you can help us with? So there, the sorghum would be the starting point, and then we talk about the good things about sorghum and what might be some downsides, and how processing can take care of those downsides, those challenges, and apply it to whatever might be the best product suited for grain sorghum and the kind of processing technology I'm working with. So that evolves into eventually an application. It could be a gluten-free pasta as an example, or gluten-free cereal, and grain sorghum is a good ingredient for that. But the starting point is really grain sorghum. It could be sorghum farmers. So I've had in the past the Sorghum Checkoff, which is a national organization of sorghum farmers, who would approach me and say, hey, can we promote grain sorghum through you and through your work, and how do we find more applications so farmers benefit? So again, starting point being the raw material. In some cases, it would be the end product. So I do have a lot of people, folks in industry call me and say, we want to develop this plant-based meat product, and we want it to be of the best quality, mimicking a certain actual meat, animal meat texture. What would be the ingredients we should work with, and how do we process to get to the right quality? So there, the end goal is kind of the product, and we have now a range of materials to work with to get to the product. So really, it can be both, and so research in my area could start from either ends, from the raw material side if there's an interest in that direction, or from the final product. So it does vary depending on who would call me or where the opportunity is. So, but both are challenging in many different ways. So
they're really interesting projects, and when we think about one of the grand challenges that gets outlined often, it's food security. And I noticed that you have some activity in Africa, is it, or some projects that have implications for food security in some of the developing countries. I was wondering if you could talk about that a little bit.
Yeah, that's correct. And in fact, one of them was in fact related to grain sorghum as well. So that's another one of those projects when the sorghum checkoff, they contacted me, and they said, hey, food security is a huge important area where the US government contributes, and US taxpayers also contribute, worth hundreds of millions of dollars. It also benefits our growers. It also benefits our manufacturing companies like say Bunge or Cargill, who get involved in making some of these products which can be shipped out for nutrition intervention and so on. So with so much of investment in this by the US government, US taxpayers, and also our different manufacturers and our growers also involved in it, can we figure out a way to incorporate grain sorghum in the mix? Because primarily, usually corn is a very common ingredient, rice and soybeans, those are common ingredients, and those are great, but they were interested in seeing how can we incorporate sorghum in food security efforts. Also from a point of view of sustainability, because sorghum is a very sustainable grain, and if you wanted to carry this forward and have those countries where we're targeting the food aid be more self-driven, then grain sorghum is a great crop, because it requires bare minimum inputs, water and other inputs. So it could be actually grown over there and eventually in the target country, and that might be even easier than some of the other grains if you wanted to have a sustainable solution. So they came and talked to me and say, hey, listen, can we use grain sorghum in food aid applications? And we are willing to fund you with a seed grant, like the Global Food Systems Grant. And with that initial work, maybe you can go for a bigger project. And obviously, when you have an opportunity like this, you definitely would jump onto it. So we wrote a small proposal for the checkoff. It got funded to explore sorghum as an ingredient in a product called fortified blended foods. And these are really porridge mixes. They are dry powders which have been pre-cooked, and at the consumer end, it could be a home in Africa where there is an undernourished child, and the mother would take the dry powder and just cook it in boiling water, and maybe add a few things to it, but be ready to consume. It will have all the calories, all the protein requirements, and micronutrients as well, especially vitamin A, iron, and so on, and also should be tasting good, so the kid can consume it and really benefit from it too. So can we incorporate grain sorghum in that kind of an application was a challenge. So we wrote that proposal. It got funded by the sorghum farmers, seed money. It turned out to be a great project, 1 year long. And in that time frame, the sorghum farmers and the sorghum checkoff were also talking to the US government, the US Agency for International Development and USDA Foreign Act Service to bring grain sorghum to the fore. And it turned out that they had a big competitive program for supporting food aid-based projects. So I applied based on the already data that we had got and the support we had from the sorghum farmers, and it turned out to be a huge $5 million project which got funded, multidisciplinary, involved folks from nutrition, and so which included nutrition experts, nutritionists, but also sensory analysis experts, we had an ag economist, Dr. Nina Lilia, was part of the program, and me. So 4 or 5 people in the team. We also had a maternal and child health specialist in the Sandy Proctor in nutrition. She was also part of the team. Brian Linshield as a nutritionist. Edgar Chambers was the sensory guy. So truly multidisciplinary. We put together the proposal. We were lucky enough that they found it to be one of the topmost ranked among a very competitive bunch of proposals. And it was a 5-year project, and that involved actually a lot of work in Africa, especially in Tanzania. So these products and the processing all was geared towards making the right kind of sorghum-based fortified blended foods, which could be then sent to Africa for a field trial with about 2,000 kids. And these were kids, young kids from 6 months to 5 years in age. And eventually the trials, we did a lot of work in our lab over here at K-State and nutrition and sensory, and developed these products, also the processing behind it, and a lot of fundamental work in understanding sorghum as an ingredient, how it processes, how it thickens as a porridge, and so on, and compared with corn and other ingredients. And eventually we had about 200 tons of this product made in my lab, shipped to Tanzania, and we did a field trial 6 months long, and monitored the young children's nutritional status, iron and vitamin A and so on, over a period of the 6 months. Worked with the mothers as well to make sure that the food is actually consumed by the kids. So there's a lot of community-based work as well in the villages in Africa. So I've traveled several times over there and developed a great network. The end result was, it turned out to be extremely efficacious, the sorghum-based fortified blended foods, and it was highlighted in various forums. The US government noticed too, and it's an ongoing effort. To make changes in the food nutrition basket, it takes a long time, and there's a lot of hoops to jump through it, but definitely sorghum became the front and center in the discussion, even in the USAID and USDA Foreign Ag Service circles, people who make decisions on these big projects. So that was an example of a project in Africa. And in fact, I met Maureen in Africa during those times in Ethiopia. She was working on another project, and I was there working on a separate project. So have definitely traveled a bit in Africa to work on food security-based projects, and this was an example.
The technologies that it takes to develop that product, are they easily transplanted to Africa so that they can build an industry around this?
That's again a great question. So from the very inception, sustainability, not just from an environmental perspective, which was indeed one focus, but also sustainability in terms of, can this carry forward? Can this have self-sustaining momentum in the target countries, including Tanzania? So that was part of how we designed the project. So of course, choice of the grain, sorghum was one important aspect because it's grown in Tanzania. It's a commonly consumed grain. So that's one aspect of it. Also the technology that we picked within extrusion, we have various kinds of options available. So we chose the option which was the cheapest and which is most likely to be found in a, say, city in Tanzania. That kind of a processing system. You could go to a fancier system and it'll give you probably easier to make a better quality product, but we went to the cheapest system possible, and we have those different options in my lab too. Thinking that yes, someday it'll be taken up in Tanzania, but they need to have those things in place. They need to have some kind of a production facility, and obviously the right system geared for that, momentum would be definitely helpful. So yes, we did plan it that way, and eventually it did help us. A big part of that project was also the economics of it, and how it will be in terms of there's one aspect is shipping products from the US to Tanzania or Africa. The other aspect is producing it, or what they call local and regional procurement. So that's where Dr. Nina Lilia, the economist came into the picture, and she studied both angles. What if we source sorghum locally? What if we source other components which go into that product locally, versus if it was done in the US? So the economic comparison, and also the processing costs here versus in Tanzania. And so that was an important part of the project, the economics and how it could be sustainable. So, and yes, indeed, the technology developed is definitely implementable in other countries, including in Africa.
As you said, we met in Africa a couple of years ago during different trips. Now, the group I was traveling with was Feed the Future Lab, which was working in the area of sorghum as well. Was your travel attached at all to the Feed the Future Lab
Indeed.
systems?
Yes.
That's
yes.
okay, which is, just for the folks listening, Feed the Future Labs are a USAID supported, I believe, activity.
That's correct. Yes. And indeed, so the lab we were working with is the Post-Harvest Innovation Lab, and part of that lab's goal, and this was Ethiopia, but they have other countries in their purview. But we were looking at a different technology. This was solar drying of grains, still grains, but drying of grains for preservation right after harvest. So part of the reason I was traveling in Ethiopia was to work with local universities. There were two main universities, Bahir Dar University and Mekelle University, where we were trying to implement solar drying technologies for drying grains produced locally like teff or wheat and other grains. And I was there to help the students over there and even the faculty, mentoring them to do some research around different models of solar dryers, and also try and commercialize that technology or make it sustainable in Ethiopia. So that was the main reason, but it also evolved into nutrition and some aspects of value addition, because grain, especially if you have a lot of losses in grain, one big reason is that it just sits in storage and it's not being used for any application. And the more it sits, the more likely there will be more losses. So it kind of evolved into even looking at how can we, do value-added processing and take that grain up the value chain fast enough so we don't even require that much storage, and it can be packaged and marketed and so on. So because coming from a processing background, beyond just solar drying, we started even exploring and working with those university partners in that direction as well. So that was part of what my role was in the project, and traveled to Ethiopia a few times, and was definitely a great learning experience for me as well.
That's wonderful. I learned so much on that trip, and when you get into a country like that, and I'm sure others in Africa are the same, you realize how important it is to bring the technology you're working on down to a very fundamental level,
Right.
so that it can be used in areas where things
Indeed.
like electricity are not always available, or
Indeed.
equipment to do some of the things that we do. I recall watching a group of folks in Ethiopia winnowing teff by hand. And it was a very large amount of it, and the skill involved in doing that was amazing.
True.
Just amazing. But you have to think outside of the laboratory sometimes when you go into some of these areas.
Absolutely. I think one of the things that I noticed also is, for example, we're working with this different technologies for solar drying, but there was a special solar bubble dryer, and very effective, but there were some challenges in actually using them in the field. On paper, it's a great system, but then you need to have a concrete platform, and you need to have good enough area as well. So some places in Ethiopia can be very hilly, and Ethiopia is still better suited, but same technology was being implemented in places like Guatemala, where especially it's very mountainous, where you don't even find a big enough flat space to lay that big solar dryer on the ground and for it to be flat and so on. So then you had to adapt it, and so not everything works as you would think it would in a different country. So it looks great on paper, but you have to really adapt it and see how it will actually be implemented in that target country. So indeed.
This broad area of agriculture, considering the challenges we have, are there some areas or opportunities that your skill set are particularly valuable to that we just haven't tackled yet, that we need to get to, that could solve some of these problems like food security or certain environmental things? Are there food systems, production streams that are generating a byproduct that we could turn into a valuable product or something like that? This is not an area I have paid enough attention to. So I'm just wondering if there are some opportunities where we just haven't taken advantage of yet.
I would say, obviously, a lot of the opportunities have been explored, but there are some which definitely need continued exploration, and some which have not been explored. So they're definitely in the area of processing, in the area of energy usage, for example, or more efficient processing with minimal energy, minimal water usage as well. That's another area. So all of those things are now coming to the fore more and more. As things evolve, you can clearly see how sustainability, environmental sustainability is becoming a huge deal. So at this point, I think it's still in infancy, but this is something I'm really interested in, and that's part of what I've been doing. But as avenues are opening up, I think that's the direction to go, is really looking at energy sustainability and water sustainability in processing. Now, you do look at sustainability in crop production systems, and there's, for example, an innovation lab, which is Sustainable Intensification Lab, which looks at sustainable production of grains. But processing-wise, I think it's still in infancy. Industry is looking at it extremely carefully, and it varies depending on where you are. Europe, for example, they are way ahead and looking at carbon footprint when it comes to processing and energy usage and water usage, and they're monitoring it closely, and they might even have some labeling of that in food products. The US is probably headed over there in the next, say, 15, 20 years, but the research is lagging, and that's where me as a processing engineer, I think we can contribute and work with, really throughout the food chain, from, say, growers, sustainable production of grains, all the way to packaging and transportation, the whole value chain, and how do we look at sustainability, look at the carbon footprint, and understand how we can minimize it. So processing-wise, I think it's still in infancy, and we don't even teach a class on sustainable processing, for example, at K-State. I don't think there's a class in bio and ag engineering or grain science or in food science. So you can clearly see there's a niche there, and which is a growing area. I do know some other places within the US, they might be hiring faculty who are actually specializing in sustainable processing in food, and which is a great multidisciplinary area. So it encompasses more than just, say, food science or food engineering or one aspect of food science. It brings together lots of different areas to bear into this sustainable processing. So I think that's one direction where I see a big role for people like me with my background, and also collaborating with other folks who can help us with understanding how processing can be made more sustainable. So indeed, that's an exciting area and becoming more and more relevant in the current world.
Well, I can see that one of the areas that you were working on is in the area of biodegradable packaging materials. And this is in a couple of the different things that I'm working on, whether it's within the city of Manhattan or the university proper, is looking at how to reduce waste. On the food side, sometimes it's food waste, but as many times as not, it's packaging waste, and a huge impact that's having on our system. Where are you in that kind of research? What are the roadblocks in getting that out more into the mainstream?
We have done a lot of theoretical work. We also had a USDA NIFA funded grant a few years back to explore, I think about $500,000 to explore biodegradable packaging, and usually this would be starch-based, or it could be protein-based as well. It was a multi-university project. NC State was a partner or a PI, and University of Tennessee was also part of it, and us at K-State, we were the main PIs. So we were looking at these different bio-based materials, starches or proteins, as the base material for sustainable packaging, which could be bio-based, so based on biomaterials, but also biodegradable. So that was a good project. Also a lot of theoretical work behind it, looking at the starch chemistry or the protein chemistry, and how we can use nano fillers to make nano composites, which improve the properties of these materials. And that's one of the drawbacks of many bio-based materials or biodegradable materials. The performance is not as good as regular plastics, and that's one big reason why no one goes for it. And the second is cost as well. And when it's performance, it's things like how strong it is or how flexible it is. If it's food packaging, flexibility is important. It shouldn't break, for example. It should also be a good barrier to moisture and oxygen, which is a big part of keeping food shelf life extended. So those are criteria where plastics are really good, and that's why they're preferred. And so it's very hard to go away from it. But the challenge in research is how do we improve the performance of, say, starch-based or protein-based or some other biomaterial-based packaging which has a similar performance criteria. So that's part of the research we did. But also over the years, we realized the industry is really interested in it. We had big companies, including a multinational company as well, who approached us, who gave us a lot of funding, supported a graduate student as well, to explore bio-based packaging because it was part of their drive to become more sustainable. And so they're extremely serious, and that just tells you about how it is in industry as well. More and more it's coming to the forefront. It might be more costly, it might be less in performance, but they're looking at ways to improve both aspects, make it cheaper, make it better performing. But the challenges are, in cost, in how good the quality of the packaging material is, and that's what slowly I think we have better options now. An example would be, say, PepsiCo or Frito-Lay brought out packaging for sun chips, and they especially marketed as bio-based packaging or biodegradable packaging. And so that's one example of how industry has gone towards that, and so those companies are working with us to help them in that goal. So indeed some challenges, but I think one of the things which will change things in the future is as regulations come in place, and regulations are good and bad, of course. Industry doesn't like regulations, but at the same time there ought to be some regulations to take into account environmental issues and such. But at some point or the other, regulations would be what would be another driving factor in adoption of these technologies for bio-based packaging. So I think we're getting there, and we do see a lot of commercial interest in that area. We have helped in at least providing some momentum to that movement.
I'm going to ask this question. We may have to cut it out because it may be an unfair question. Is there a reasonable timeline to put on something like that? I mean, when will we see Frito-Lay, General Mills, all of these companies using truly biodegradable materials to package their foods?
I don't know if it would be in the next 10 years. I think probably next 20, 30 years, technology will catch up, and other aspects like I talked about, costs will go down, and in that respect, maybe eventually we'll come to a more bio-based packaging scenario where it will be more common than what is right now. So right now, these are really novelty packaging materials at this point, and a few products here and there, but not as a norm, obviously. So, but I think it's going to be in the horizon 15, 20 years, somewhere in that time frame.
You mentioned, in your introduction, your discipline and your program, it involves engineering, it involves physics, it involves chemistry, and I'm guessing a little bit of microbiology thrown in as well. I'm curious, what's a curriculum like for your students?
Yes, I'm actually teaching my extrusion class this semester. It's an undergraduate class. We have 15 students, and so it's always a fun challenge for me. A lot of these students don't completely come prepared, at least mentally, for what they might see in my class. So yes, indeed, there's physics in the class, and there's some math, and a lot of times our students freeze when they see numbers and when they see some equations out there. So my challenge is how to make it fun. So the way we do it, I just came from the lab, and I was telling Maureen and Jared over here that I'm wearing my work boots and wearing a more formal coat, and because I was in the lab and then I threw a coat on, I wasn't sure if it was going to be a video podcast or an audio, but I was working with a student class. So this is one of the ways I kind of get them engaged. Our students are very hands-on. When they see numbers and equations, it's all good, but they can't connect to how things actually work unless they actually do things with their hands. Now we do have labs, and labs are a great way to show the practical aspects of what they learn in class. But I really try and pull these students individually and give them the incentive of giving them extra credit. And I say, hey, you'll get some more points in the next exam why don't you come and work with me in the lab for a couple of hours, and let's put the extruder screw together, these metal parts which go in the extruder, or let's spend some time mixing the recipe. We do 200-pound batches and several batches, so this student was there mixing corn flour and oat flour and some wheat starch, and so getting a more hands-on feeling. And as they do more and more, I realized, then they start to appreciate what they learn in theory, but it's always a challenge. So my goal is to get them into the lab, besides the formal lab, with all kinds of incentives, extra outside hours, really, to spend as much time as I can with them, and see if they can benefit from the experience, plus get some extra credit points too. So, but it's a challenge, and how to keep them engaged. And so yes, indeed, there's math and there's physics, and yes, there's chemistry also involved, because food components, if you want to understand them, they're really molecules, and when you talk about molecules, there's chemistry. And then of course there's microbiology, because food safety is a big issue, and how processing can impact food safety and microbial loads and all that kind of stuff. So yes, it's an integration indeed, which makes it a challenge, but it's also fun. And the students, I think they, over time during the semester, they slowly kind of get into it and start enjoying it. And that's my goal, is not to make it about just grades. Let's just get over with the grades. You'll get good grades, but let's start learning a little bit too. So that's what I do with my class.
So do you have crossover students from other areas that come in, or are they mostly grain science?
They're mostly grain science. Sometimes we do have students from animal science or food science in those classes too. So, but the core is grain science, but we do have students from other disciplines.
Well, I do recall taking those extrusion classes when I was working on my PhD, and it's a different world. I mean, it's the engineering side of it is heavy, and
right.
There are a lot of things you're introduced to as a food science student that
Absolutely.
are not familiar.
True. Yes.
I was wondering about graduate students, like master's or PhD students, where, when they go through your program, where do they go?
A great question. And it's always fun to keep track of them and see where they are. And so a couple of them are now professors in different universities. So they chose the academic line, but most of them are in industry, be it after master's or PhD. And they really get snapped up pretty fast. So we have people working in companies like PepsiCo, and people, we've got to think about now, working in very specialized extrusion-based companies where they might need the extrusion expertise to, really run the facility and also run the R&D lab. There are students who are in ingredient who work with ingredient supplier companies. So where their extrusion expertise can be used to really market the ingredients, because these ingredients would be used by manufacturers down the line somewhere. So they might have a lab which has extruders in there, so that expertise or the learning they have in the master's or PhD, they can apply in that R&D facility. So it's a mix of some folks in academia, definitely fewer in academia than in industry. Mostly they're in industry, and in a wide variety of companies, including pet food companies and food companies, multinationals, and also smaller companies as well.
It might be worth listing some products on the market that people would be familiar with that come out of an extruder.
Sure.
When I worked in those areas as a graduate student, and actually in my position at AIB, we used to go down and use your extruder to make rodent food bars for the NASA
Right.
flights.
Yes.
Totally different texture, totally different kind of product than some of the other kinds of things that come off.
That's
of it.
correct.
So it might be helpful for people to
Sure.
understand what does an extruder do.
Sure. So those, the rodent food bars that Maureen mentioned, they were really an interesting project. So that stuff, you tell our students to kind of wow them, is the stuff that we make in this lab would go to the International Space Station for experimentation. So that's really one application. But a lot of the applications center around products like breakfast cereal. Example would be Cheerios. Actually, we're making some Cheerios-like products as part of my class in the lab. Tomorrow we'll be doing it. Last Wednesday we did some of that. So I was just talking to my colleague, my operations manager, Eric, and we're talking about how tomorrow when students come in for lab, how we can make them coat the Cheerios that we're making with the extruder with sugar, with a sugar syrup. So that's part of what we're doing. So that's an application. So Cheerios-like products, breakfast cereal. We also do work in snacks, savory snacks. So one of the first couple of labs that we did in this semester was really trying to make Cheetos in the lab. So, and these are of course class projects, but when it comes to industry clients, those are the kind of needs they have. Develop a newer snack for us, or develop a novel high fiber snack product which will be healthy for the consumers. Or can we use some novel ingredients like sorghum to make breakfast cereal? So those are some applications which come to mind. Plant-based meat is a huge application. So really meat replacement products based out of pea protein or wheat gluten or soy proteins. We have clients who, this is really big these days, so we get a lot of calls for them to use our facilities to develop a new plant-based meat product. So that's an application. So think about Beyond Meat or Impossible Burger, those kind of products. So we do a lot of R&D with different companies, not these companies in particular, but similar companies who are in the same space. So that's another application. Pasta. So one example is pre-cooked pasta using, again, grains like sorghum. So we work with companies in that area to develop products which they can market as gluten-free pasta. So that's another application. A lot of work we do is also pet food. So a lot of the R&D work that we're doing is for understanding pet food quality and pet food processing, and how, say, nutrients might survive or not through the extrusion process, because it's very high temperature, high pressure. To understand that, because nutrition is especially important for pets, unlike humans, because one kibble of pet food has everything in it, really all the protein and carbohydrates and micronutrients. So if there's some deficiency, then it affects the pet very fast. So you want to have a good nutritional profile. So look at processing and nutrition and when it comes to pet food. So those are some applications that we've been working with.
Maybe just a little bit expand on plant-based meats. And what does that really mean? What is your starting point, and what do you actually end up with?
And this can be also controversial sometimes, because people might say that, are we trying to replace meat? But some people will say, hey, that's never going to happen, and why are we even going down that direction? So I think it's more about really providing people more options. And there is a huge, growing, let's say, segment of the population which is looking at things like, especially the younger people, sustainability. They're looking at animal welfare, those aspects. Maybe health also is one factor. So to cater to that segment, and it's growing fairly fast for it to be a big market already, growing at a rapid pace. So the idea behind this is to use plant proteins, so really non-meat or non-animal derived proteins. So they could be soy-based or say other legumes like peas or beans, or cereal-based proteins like wheat, gluten. And how do we take those plant proteins and process them, cook them? And the real challenge is animal protein or animal meat is fibrous. We all know this, but plant protein is not. And so how do we make, through processing, these plant proteins into more fibrous-like texture? So that's the challenge, is to try and get to the texture. So that's part of what we're doing with plant-based meat, is taking plant proteins, cooking them, processing them in an extruder, making them fibrous during the extrusion process. And as it comes out, it's very layered and it looks very much like meat. Taste is still a challenge in some ways. Texture, again, there could be some places where definitely there can be some improvement. So those are kind of things that we were studying with the Global Food Systems grant as well, and we put in a huge, bigger USDA proposal recently, multidisciplinary, including some partnership with engineering as well here at K-State, to understand this better and see how different ingredients and their functionality can be manipulated to improve the quality of plant-based meat. So those are kind of research areas that we are looking at. And that's really what it is, converting plant proteins to more meat-like texture to be able to mimic meat and not entirely replace meat, but have another option in the basket of options available for consumers. I'm not sure if I was kind of rambling, but I'm not sure if I answered your question.
No, that was actually quite good. And I was just wondering about the starting point. You know, are these actual, when you talk about wheat gluten, are you starting with the wheat grains, or is the gluten a byproduct from gluten-free? I'm just wondering where this process begins.
So primarily, yes, it's really isolated protein. So whichever grain you have, soybeans or wheat or peas, so you isolate the protein. So the component you're working with eventually would be much higher in protein than the original grain. So when it comes to wheat, wheat gluten would be extracted from wheat, and that's what would be the starting point for plant-based meat products based on gluten. When it comes to soy, again, soy isolates or soy concentrates, which are higher in protein than soy flour. So again, concentrated forms of proteins derived from grains are really the starting point for these products.
I'm not sure how to ask this question. One of the other areas that you have listed that you do a fair amount of study on is rheology.
Right.
And rheology, you might explain what that is, what that even means,
Sure.
and how it fits into some of the things that you're working on.
Absolutely. Yeah. Rheology is a very, I guess, less known term, but really it's a science of flow of materials. So whenever we're talking about processing involves flow. You have to make the material flow from one end to another to be able to cook it or to be able to transform it. So rheology is understanding how materials flow, be it in a liquid state, and you could have lots of liquid food materials, including say sugar syrups, or being in a kind of a semi-solid state like dough. And so we do study rheology of flow of doughs and other food materials to be able to relate them to processing and processing efficiency or energy requirement for processing and those aspects. So, and in turn, rheology of any ingredient or how it flows would impact the end product quality as well. So, because all of that is very closely related. So that's where rheology comes in, really the science of flow of materials, and in this case, food materials. So let me ask you guys a question. So. Again, plant-based meat. Have you guys tried plant-based burgers and that kind of stuff? How about you, Jared?
I've had the Impossible Whopper from Burger King.
Okay.
I thought it mostly tasted similar, honestly, to a regular Whopper. Someone didn't tell me there's a difference. I maybe wouldn't have been able to tell.
Is that
But
right?
obviously it had all the toppings like lettuce and onion and ketchup on top of it too. So.
Right. So it was reasonable in taste, but maybe not something you would have on a regular basis, but
Yeah.
good for a change to try something different. How about you, Maureen or Jim? Have you tried anything?
I've, as with Jared, I've tried the Whopper. I have
Okay.
not purchased at the grocery store. I've not
Right.
tried purchasing some. I definitely knew the difference. if
Right.
any.
Yeah, you can see the difference.
Yeah,
True. Yes.
absolutely. But it was not objectionable.
Right.
It was better than I thought it would be.
Right. It's almost like a different category of. It's not necessarily a meat replacement when you do it. But what do you think, Jim?
I do enjoy a black bean burger from time to time, but not the plant-based meats.
If you start looking at it as a meat replacement, it doesn't feel like it, but it's a whole different category of food. So yes, it's fibrous, it has a different texture, and it's still plant-based. So I always give an example of whole grain bread to students and other folks. When whole grain bread first came into the market, people didn't like it. They used to refined bread. But they knew, in this case, and in the case of whole grain bread, not necessarily true for plant-based meat, but there are various angles to it. But people knew that it's healthy for you. So that's why the first time you try it, you don't necessarily like it, but since it's healthy, you might try it again, and you might try it again. Over time, you get used to it, and your expectations change. And so that's the case with me as well. And now I don't prefer anything but whole grain bread. When I have refined bread, it's just too, it has more mouth packing, tooth packing, and it's just not the same texture. I like the little bit more of a chewier whole grain bread texture, so I started liking it. But that's just because of repeated exposure to it, and my expectations changed over time. So same goes with plant-based meat. You could probably never have a product which is going to be like actual meat. But as consumer expectations change for various reasons, So the bar would be changed, so to say, or I don't want to say lowered, but be a different bar, and then you might be able to get more people to be able to like it or accept it. But as long as they're comparing this with meat, it's not gonna really, fit the bill, so to say.
Do you expect that over time, I mean, from a marketing perspective, I can see how maybe that would be just separated off into not a meat category, but a category all its own.
Right.
So as you said, the expectation wouldn't be that it's meat.
Right.
It's something different than that.
Yeah, that's true. Then that's where eventually, from a marketing perspective, it might be better than always try and imitate meat. So, and there are different other products out in the market which can imitate meat better, which can be more, say, animal friendly. For example, cultured meat, which is actually still meat but comes out of a lab rather than a live animal. So that could address, animal welfare concerns. Plant-based meat, yes, so it might need to be marketed differently and could be a whole different category of products out there.
I was thinking about this just before you brought it up. Do you know if anybody's actually looked at the energetics or the sustainability or the carbon footprint of plant-based meat versus cultured meat in the lab?
Well, that's a great question. I don't know about cultured versus plant-based, but I do know of people and research in the area of plant-based meat versus regular animal meat. So, and there are various viewpoints and sometimes conflicting data as well. I've, for example, come across some research and including a presentation at the Cereals and Grains meeting a couple of years back in Denver, where there was a USDA scientist who had data which showed that actually it's not necessarily more sustainable to have a completely plant-based diet. It might be more sustainable if you have a balance of animal and plant-based diet. So those things, the data can be conflicting and not completely, very clear. So I think to market it as very sustainable, from an energy point of view or carbon footprint point of view, might be premature, because I think the jury is still out there, and maybe there is some truth to the fact that purely plant-based meat might not be, or plant-based products might not be really the best option. A good mix might be the better option, even health-wise too. So a lot of people do it from a health perspective, meaning shift to a plant-based diet. But again, a good mix of the two might be better than just plant-based or very heavily animal-based. So, but no, cultured meat versus, to answer your question, on plant-based, I'm sure people are working in the area, but I just don't personally know of data in that realm.
Well, we are coming up on the hour very nicely, and I appreciate your input and coming over to visit with us today. Do you have any other questions for us? We had one good one already here. Are there any other questions or things that you would like to add? Maybe something that we didn't think to ask you?
Well, I must say, first of all, thank you for inviting me, and this was a great experience and also very conversational. Fun talking to you. I don't know if there is anything more except to say, to the audience who might be eventually listening to this podcast. Hopefully, there are some young students out there too who are interested in studying food processing, studying food science, and agriculture in general. And I wanted to say that there is a lot of, in the future and in the coming years, there will be a lot of opportunities in agriculture from a point of view of sustainability, from a point of view of healthier products, and just the way this world is going. I think there will be more and more need for trained folks in agriculture in general and in food science and food processing. And we are here to, work with you and learn in the same vein as well. So a lot of opportunities, and would be happy to answer any questions if they are interested in communicating with me.
If you have any questions or comments you would like to share, check out our website at ksu.edu/research/global food and drop us an email. Our music was adapted from Wayne Gowen's album, Chronicles of Carmela. Special thanks to him for providing that to us. Something to Chew On is produced by the Office of Research Development at Kansas State University.